Hello, everyone. My name is Ray Gallen. I'm here today as a representative of the Association for Teacher Education in Europe, where I co-chair with Dr. Neus Lorenzo the Research and Development Community for Primary and Pre-Primary Education. In my work as president and co-founder of the Transformation Society, I have been studying some issues of complexity and changes in society and in industry that have very, very important consequences for all of us involved in education. And that's why I'm here today, to talk to you about the challenges of Information 4.0. Information 4.0 is a response to a development that's happening in industry right now. It's called Industry 4.0, and it represents, as some people say, the fourth industrial revolution. Now, what do we mean by that? If you look at the first industrial revolution as the coming of the steam engine and the building of machines, we've moved through a series of changes, as you see in the chart here, that can be summed up in this way. In the 18th century, humans built machines. In the 20th century, we moved into machines building machines, and then machines helping humans make decisions with the coming of cybernetics, computing, and so on. Now in the 21st century, we have a major game-changing phenomenon, which is that machines are starting to make decisions in the place of humans. And this is what makes everything different. And for that reason, a number of us have gotten together in order to form a consortium, a think tank, to reflect on the role of information as a humanist motivation, as a humanist driving force in industry, in society, and of course in education. And so we formed an international working group, which should be announced formally in Melbourne in July of 2018. But the work is beginning already, and here you see some of the organizations that are participating. And it would be really nice to see the lifelong learning platform add its voice and its participation to this project. When we talk about Industry 4.0, what we're really discussing is a package of paradigm shift technologies that are changing manufacturing and by extension other things like smart houses, driverless cars, all the rest of it that we hear about all the time. What's important is that these technologies are driven by artificial intelligence, and through it all there is a flow of big data. Big data being defined as an extremely large set of data, the kind that we can only get through the internet, that computers can analyze in order to show patterns, trends, and associations in human behavior. These are used to make predictions and so on. Now, in all this discussion about technology, you might ask, well, where is the human element? Where is, in fact, humanism? And that is exactly what we are trying to emphasize in the Information 4.0 consortium, that without knowledge, the Internet of Things is just a collection of things. And it's actually very important to include the informational component, because we are now seeing a convergence of information and technology through a series of different avenues of research that have been independent and separate, but are now starting to connect and interconnect with each other. And in these information flows, there are a large number of hidden processes. Much of the information is volatile and disappears very quickly. A lot of exchange and a lot of decision making is happening between machines autonomously of any human intervention. And a lot of the information that we're dealing with needs to be highly contextualized in order for it to be useful. Now, we'll talk a little bit more about these as we go, but let's look at this question of machines making autonomous decisions. Let's take the case of a farmer's field full of crops. In that field, and this is technology that exists today, there is a sensor. That sensor is capable of checking on a number of environmental factors of interest to the farmer. One day, the sensor picks up a plague of insects that could destroy the entire crop of the farmer. So the sensor sends out a message. The effect of that message is that a drone is dispatched to spray insecticide over the field and protect the crop. This doesn't happen, however, with a direct two-way connection. In fact, the sensor sends a message out to the internet and interrogates not a static database, but a continuously evolving, dynamic set of information that has information about what is the nature of the insect plague, what is the best insecticide to use, what is the season, what are the weather conditions, how can this best be applied with minimal environmental impact, etc., etc., etc. The only problem for all of us human beings is that we see only two parts of this. We see the input, that is the insects, and we see the output, the actual dispatch of the drone and the spraying. All the rest of the process is hidden. It's in machine code. We can't read it. But there may be things that we need to know about. For example, what if there are some kids playing in the field? They're not supposed to be there, but they are there. We don't want them to be sprayed with insecticide. How do we deal with that? How are we going to interact with these types of autonomous decisions that are being made by machines? What's driving all of this is artificial intelligence. And what you're seeing here in the diagram is a kind of schematized model of how what we call deep learning algorithms work, how artificial intelligence learns to recognize something specific. The problem is that these algorithms, which largely have been based on pattern matching, need a large amount of input data to compare to. So this is where big data comes in. It's used to train the network to recognize different shapes, forms, and so on. But if we don't get the right data in, we don't get the right kind of reaction out. Now, one of the things that is happening in artificial intelligence research today is that it's moving away from the pattern matching model to an error optimization model. And as educators, I think we all know just how important learning by error correction can be. However, we are still dealing with a case where all of the processes that go into making decisions are hidden. We don't have any kind of traceability. This is going to pose problems for us in society in general when we don't know how to trace back how decisions were made, on what basis, in case there are questions of responsibility, ethics, etc. So one of the big challenges that we have as we're developing new lifelong learning skills for this society in which so much technology is evolving so quickly is how can we interwork with robots, with machines, in order to solve emerging problems. One of the pieces of advice I would give is let's not try to imitate them, because we'll never be as good at being robots as the robots are. That's obvious. What we need to do is focus on the human strengths, the positive qualities that we bring to the interaction. For example, we are much better at being creative, and we are much better at dealing with the unexpected. So our challenge is going to be to change the way that we educate ourselves, our children, each other, all through life, in order to adapt to and work in a hybrid society in which humans and robots are constantly communicating and interacting. Institutions have already begun to recognize the need for this. One example is the European Parliament resolution on robotics passed last February. And if you flash on the QR code that's on your screen, it will take you directly to the text, which speaks to ethical questions, talks about possibly giving robots some sort of status as a person, questions of responsibility, and so on. And if some of these things sound a little bit weird or far-fetched, well, all you need to know is that Saudi Arabia has already given national citizenship to a robot named Sophia that you can see on the left side of your screen. So these are very much real and current problems. So given that we really don't know where all of this is going, given that we really don't know much about the internal processes of deep learning, robots, or in artificial intelligence, how can we facilitate learning? One of the ways that we can do that is to look at some of the skills that are going to be in higher demand as we move toward 2020. One of the first sets of skills that has been identified by the World Economic Forum as high demand is complex problem solving. And those are the kinds of skills that are needed for artificial intelligence, for working with robots, and so on. Another one are the social skills that are going to meld us together as a community, both amongst each other and with these robots that we're going to be interacting with. On the other hand, the robots are going to take certain things away from us. They're going to do things, they're already doing things better than we do. Physical abilities, obviously robots can lift and move things better than we can, but also content skills. That's something that maybe wasn't so obvious, but robots are currently delivering content at rates much, much higher than we can possibly dig up on our own. The only problem is that they are the ones that are deciding what it is that we get. So we all have black holes in our knowledge that are determined by the fact that they serve up what they think we need based on big data and all the rest of it. So we all have these gaps, and as educators we need to help people fill those gaps. But our problem again as educators is that I don't know what your gaps are, you don't know what mine are. So how do we maneuver in all that? Well, that's what Information 4.0 is designed to cope with. So what are the characteristics? The first and most important one is that information needs to be cut up into small autonomous learning molecules. So if we go back to the example of the farmer's field, we need a small bit of information. What is the insect that's there? What is the crop? What is the season? What is the weather condition actually at this moment? All of those little bits of information can be combined and recombined in different ways to suit different situations. And that means that we're also continuously updating the information. When the weather changes, that information changes in the dynamic database. When the number of insects changes, that also gets updated in the dynamic database. And all of this needs to be delivered in a way that is personalized, that is suited to the given situation. Not only that, but when we are in the process of learning something, we know what we're looking for. The big data doesn't know. The artificial intelligence doesn't know what we're looking for. It can't really predict that, at least not yet. So we need to have information presented in some way, perhaps through an ontology or some other similar system that allows us to choose what we get rather than having it force-fed or delivered to us. And that also suggests that the validity of information is going to be different than the way that we have assumed it to be until now. What do I mean by that? Well, we like information to be verified. We want to know that it's accurate. But if information is very, very volatile, if it only lasts for a very short time, how do we validate it? How do we know it's reliable? Maybe we need a different set of standards for that kind of information than for information that is longer lasting, more persistent, and information that might have something to do with health, safety, or life itself. The nice thing about this design of Information 4.0 is that it's meant to be applied across the board, no matter what you're doing, whether you're learning by doing, whether you're designing the information into a product or a process, whether you're involved in traditional teaching and learning skills. Let's have a look at some of the layers of learning that this is going to affect. For example, this boy, if he grows up with augmented reality from a very, very young age, what is his perception of reality going to be? How can we help him to understand it through his experience? This is a very explicit layer of learning that we are engaged in. But we also have to look at implications and implicit realities that we're dealing with even today. For example, the case of medical robots. We are prepared to accept when a surgeon operates on us that sometimes the operation isn't successful. Sometimes patients die. Are we prepared to accept that when the surgeon is a robot? How do we determine questions like responsibility or accountability? And those aren't the same things. Some of that is the business of insurance companies, but other of it certainly is ethical. What do we need to know as patients? How do we need to adapt to this new context in which we have medical robots working on us instead of human doctors? And then we get to a stage where we are looking at meta-realities, meta-levels of understanding, where we're combining all kinds of information. Like the boy in virtual reality, we're looking at a mix of objects here, some of which are virtual and digital, and some of which are physical. In this case, the cockpit of an airplane. And we know that most air accidents are due to pilot error, but how many of us would actually agree to fly in a pilotless plane? We know that machines are not as good as we are at responding to unexpected situations. So what we want to do in our educational context is make sure that we empower the added human value that comes from being able to make quick decisions at meta levels, like Captain Sully did when he landed this airplane on the Hudson River instead of following the standard procedure, and saved thousands of lives by avoiding a crash into buildings where people were living. What this all means is that as we move forward into this world of changing technology, we need to focus on a number of things that are going to emphasize the human value and the interaction that we can have with this new technology. So flexibility, interacting with machines, resilience in the face of change, new ethical principles that we need to adapt in order to be able to create a new job ethos that enables everyone to make their contribution in an inclusive world, and above all, a commitment to build communities that include both machines and humans in order to build a more sustainable development model moving forward. Now, if these ideas get you going and you would like to engage with us, let's collaborate. Let's work together to build a new model for education in general and for teacher education. Thank you so much for your time and for your attention.